output. So okay, let's check that out. This one, okay. Iterate over all items in environment. This is to see if variable already exists. Okay. If variable exists, delete item at that position and replace with variable supplied by user. Okay. This one, the replacement, and then return. Okay. No existing entry found. Allocate space for new entry. Increase the count. Okay. Yellow. Size of jar. Okay. We might need to handle integer overflow in this expression, but yeah, that's for the later, maybe after we finish this chapter. Okay. Now for it, alright then. First thing first, we need to check if the variable exists or not in the old count plus plus. Oh, we are not using the K but E. Right, sorry. We need to looping from the environment, right? And then what is it? We delete if we found. Okay, if we found. Okay, so if string cmp, what is it called again? Old? No, okay. Seems right. Okay, and then old sim, okay, E in the environment, and then this one, the old one, and then we delete that and place the new one with V. Okay. Fast, right? Okay, we delete the value and then we reassign the new value. Okay, fast I equal for copy, and then what do we copy here? The new one. Return. If no existing entry, replace the existing symbol with new value. Okay, we add this one. And then re-unlock. Okay. What is it again? Re-unlock. Okay, we increase the count in here, and then we resize with the new size. Okay. Advance. Size of and V seams, right, and then multiply by and V count. Same files. Okay. Copy content of L file and symbol string into new location. The new location. Into new location, Okay. we do this because the index start at 0, so we need to subtract 1 to get the, what is it, the last index, I guess. Files, the file copy, and then we copy the new one. Oh, just like this. Alright, and we got the file. Since and we count the one. Hello, Ari, welcome. We are currently on chapter 11 of the book Build Your Own Lisp. Let me copy this in the chat in case if you want to take a look too. As far as I understand, chapter 11 basically trying to implement variable, so let's see how it goes. We create the environment to change the variable or assign the variable. Okay. Malloc. What size of? Oh. Right. Symbol is char. Okay. So maybe for now we can, what is it called? Sim, something like this. Oh, wait, we are copying the old symbol. Okay, we are copying the old symbol like this. Alright, I mean, I didn't use malloc because as far as I understand, wait a minute, we still have the memory address from the abstract syntax tree, right? We have the memory address from abstract syntax tree until we delete this abstract syntax tree in here, as far as I understand. So yeah, that's basically it. Oh, I think we can do it like this, right? I think. Wait, hold on a minute. Let me check. I think this one. Oh, okay. This is the header one. Not that one. This one. Okay, so this one, right? We have the same type. Yeah, I didn't realize that previously. Maybe we can change this line. Instead of using result.output, we can change this to ASD. And well, because we are free, what is it called? Free the memory, right? We can set this to null to prevent dangling pointer. As long as we don't use result again. Okay, this should be fine. I mean, let's try to compile. Okay. Investigate. Wait a minute. Get. Okay. Investigate. Returning. Oh. This is this is kind of tricky. Oh, okay. It looks like I was wrong. It should be alpha, the value, okay, other than the environment. My bad. I mean it was called env, so I thought that the return value would be env too. Yeah. My bad. Okay. Alright. Init no cell because we changed it to false. Okay. First use in this function like what? And oh, okay, let me go back there. Put, where is it? This one. It should be an arrow symbol. Control reach of non-void function. Wait, what? Oh, okay, it should be void. Right, I mean, what should be written when we just deleting or freeing this one, right? And let me check. Okay, where is it? This one. Void. Okay, that's not what I expected. Okay, should be this one, right? Okay. Alright, at least it compiled. I mean, it should be fine, right? I haven't replaced that at all. Okay. Variable evaluation. This one, let me commit this first. To prevent tingling pointer. Reset dot output, right? Okay. Free memory. Let me check. Previously, where is it? Is it in parsing? I think this is in parsing. Oh no, not in parsing. In evaluation, I guess. Not this one. Or maybe error handling. Print. Well, let's check this instead. This one to main function, right? So instead of putting the r.output, in my case I put that in a function, right? No, not in a function, in a variable, sorry. I put that in a variable and use that like this. So for result. So yeah, instead of deleting this or free this r.output memory, maybe we can do it like this. We free the memory from IST and make IST as null to prevent dangling pointer. Because I use variable IST instead of directly using result. Output. memory on but yeah, for ASD in ASD and make that null. Hello programming plugin, welcome. Okay, currently I'm trying to read this book with Your Own Lisp. Basically, I want to learn C by building a simple Lisp interpreter, so that's what I'm currently doing, and we are currently on chapter 11, but before that I want to do some refactoring first. We should free the memory in SD. Where are you from? Okay, I'm from Indonesia. Man, make stay null to prevent dangling pointer. Let's see this goes. Then, one of the reason I place this in the variable so that I can use that. Let's see, in the parsing, I guess. I think it is in the parsing. Yeah, so that I can just use this in the print, ASD print, something like this. ASD print, ASD, right? So I don't need to type result.output multiple times. Okay, okay, we already done that. Now let's continue. Okay, we are already doing env underscore boot, right? And now we are in this variable evaluation. Our evaluation function now depends on some environment. We should pass this in as an argument and use it to get a value if we encounter a symbol type. Because our environment returns a copy of the value, we need to remember to delete the input symbol eval. Okay. Alright. Okay. Interesting. In this one, right? If okay, first thing first, let's change the header. Where is it? This one. Struct lf. Okay, barely fit one line. Okay, and then change this one. Env. Okay. If if right value type equal. Oh, okay. Same, right? Struct alpha. What is it called? Let's call it this one using X, right? What do we get again? The variable, where is it? Okay. We are getting the symbol, okay. Or far. Let's call it symbol for now, at least. Where is it again? This one. Alpha. Get. No, not alpha. And we get. What is it? We get. What is that? And v and then value, okay. And then we need to delete that. I do not copy the value. We need to remember to delete the input symbol. Okay. Free the symbol. And then return symbol. Okay. Because we have added a function type, our evaluation of symbolic expression also needs to change. Evaluation of symbolic expression also need to change. Instead of checking for a symbol type, we want to ensure it is a function type. Oh, function type. If this condition holds, we can call the fun field of the L file using the same notation as standard function call. Alright. Okay, I think this one is the same. Follow it. This one, if we got an error, okay. This one is the same. Well, let's compare that. Okay. Right, this one is this one equal to this one, or well, in my case I combine this two. What is it called? Two loop into one loop. Right, I mean, I'm not sure if we need a spirit looping, right? For evaluation and the error when we evaluate the expression. Okay. And then this one, right? First element is a function after evaluation. Oh, okay, so we change this one, which in my... Where are you from? Okay, I am from Indonesia. Welcome, welcome. Alpha fun. Okay. Looks like... Wait, let me read again the explanation. Because we have added a function type, our evaluation of symbolic expression also need to change. Instead of checking for a symbol type, we want to ensure it is a function type. Oh, okay. Condition hold, we can call the L file using the same notation as standard function call. Alright. First element is not a function. That is interesting. I mean, are we not checking the symbol again? Okay, and then this one, first element. Does not start with symbol. First element is not a function. It's not a function. Okay. And we also delete the first. Alright. Answer okay. If so, call function to get result. What is the alpha fun again? This one, right? Okay, so we're not using built-in, but call the function to get result. Okay, what is E again? Oh, okay, we also need to change this, the parameter. Okay. fang, okay, and then env value. To that we delete this one. Let's do it like this. Okay, and then to put in. Note that our evaluation relies on the new function type. We need to make sure we can register all of our built-in function with the environment before we start the interactive prompt. Evaluation relies on the new function type. We need to make sure we can register all of our built-in function with the environment before we start interactive prompt. We can register all of this one, right? Register all of our built-in function with the environment. Start the interactive prompt. Okay, let me check the alpha function again. Okay, we allocate the memory. There's a mosquito going around. Right, alpha fun. Okay, fun. We need to change their type signature. At the moment, our built-in functions are not the correct type, right? We need to change their type signature such that they take in some environment, and where appropriate, change them to pass this environment into other call that requires it. Alright, I won't pass the code for this, and change the type signature of the built-in function to take at the sample code. Okay. The type signature says that they take in some environment into other calls that requires it. Built-in functions are not the correct type. Alright, let's check. Built-in this one. Okay. Okay, so at first we have this pointer char, right? So we change that to env. As their first argument now. that out. But then, how do we compare? Yeah, like, how do we compare that? I'm kind of curious. Let's check this out. Okay. Where is it? So we changed this first, huh? I mean, okay. I think we changed the built-in operator. Huh. Interesting. And then we changed this built-in function with this one. I assume, where is it? This one. I mean, yeah, there's a lot of function name built in. If you know what I mean. There's a lot of function name built in, so which built-in are we talking about in this section, right? Maybe, just maybe, is this one built-in operator. Maybe, just maybe. Okay. It is .c. Where are we? That already implement this. Okay, in this one, right? Take. So. Okay, we already have this. Oh, okay. Value, right? And then we take this. env. Okay. I mean, there is still an operator. So can be quite lengthy. env. Now, how do we use that? Okay. Here. Good luck with your study, my friend. Thank you. Welcome, and Wantaru. Yeah, this is getting a little bit harder, but that's what interesting, I guess. Where should we implement this one? We have built-in operator, right? Built-in operator, and then we are passing the environment and the value. Previously we have the value. Add built-in function. Like what? Oh, the difference between using S and not using S. Yeah, this can be confusing. Yeah, I'm not sure what is the goal in here. Like, we have the environment. What should we do with the environment? Let me check the example, I guess. Built in. Built in head. So we add a new macro. Okay, interesting. Put in eval, put in join, put in operator. Okay. Okay. This is, I think, still the same, right? This one, I just adding the extra step. I mean, it's basically just the if, the usual if rather than the macro. And then this one, wait, let me cross check first. Alpha assert type. Assert type. Okay. Okay. Alright. Assert, right? So this is the conditional, and assert is actually a negation of the conditional here. Okay.
Yeah.
Correctly type for God. Okay, expect. Alright. So we need to assert the type first, huh? What should we write? Need to assert the type first. Let me check. This one, okay. Cannot operate on non-member. think. Wait, do we need A and I in the assert type? Let me cross check again. This is fun. Argument index expect arg cell, okay, and then with the index, okay, type, and then expect. Let's check. Cell, well, because we put this in new variable called cell, right? Cell type, okay. Arg is the value, cell, well, the cell, and then there is this index I, okay, the type, okay, so this is basically the same, right? It's just having the different error message, I guess. Alpha error. This is interesting. Like, what is this? See, arcs. In macro means, okay. Basically understood is passing argument, but I don't understand what this three-dot notation is called. With simple example or profiling. Oh, there's a variatic macro, okay. It means you can call it with any number of arguments, okay. The three-dot is similar to the same variatic function, right? We already learned about this previously. It's basically having as much argument as we want. What is it called? Maybe something like dynamic parameter or argument. Okay, that means we can use the macro like this, or with any number of arguments. With respect to the variable argument in the macro itself, would be replaced with print string, okay. Alright. But the interesting part, do we need this one? The what is it called? The symbol. The symbol. I don't really know what it is called. Okay. For LFMT. Oh, we also changed the alpha R implementation of the function. Oh, okay. Interesting. Where is alpha R? Wait a minute. there is a lot going on in this chapter. This one. Oh no. We are using variatic function in here too. I mean, VSN sprint F. Wait, I remember. Let me cross check first. I think VSN not in here. Okay. There is some comment in this parser about not ASCII standard or something like that. Let me search for that first. Where is it? Where is it? It's not in here. MPC error string. Not this one. Okay, not this one. Okay, this one. Oh. SN printf is not ASCII standard. It's not ASCII standard. Okay. Let me check. C programming VSN printf. Okay, let's see. Very old. I'm getting sick fault within a custom written wrapper. Apparently its task is to detect duplicate output string and intern them. VA list right from the variatic function and the allocated space. If that works, return the string. Let's try again with more space. That the standard returns the number of characters written and simply returns VSN is this like POSIX compliant? That's oh, okay. Okay, it's not ASCII standard. Okay, but it exists. Interesting. Right? No, not that one. Okay, VSN printf char size pointer to constant char. Simply returns a sentinel value if it doesn't receive enough space to format all args. This means that you can just guess a buffer size, increase it if necessary. But on my system, Ubuntu VSN print cause a segmentation fault when called with too many arguments for the provided space. Did the semantic of the family change that drastically in the meantime? And what is the mode of ensuring you had enough buffer space? And do not write more than size byte, including the terminating null byte. If the output was truncated to this limit, then the return value is the number of characters, excluding the terminating null bytes, which would have been written to the final string if enough space had been available. Thus a return value of size or more means that the output was truncated. Side issue and more than easier to follow. Forever if encoding error occurs that is not due to insufficient space. Right. This is every operating system except so your problem is somewhere else. I'm almost certain that your problem is that you're passing the FA list app into which consume it, and then you expect it to be reset on the next call. This is incorrect. Stop blocking in GCC on certain architecture. VA copy. What is VA copy? C programming VA copy function. Macro copies src to test. Should be called on test before the function returns, or any subsequent reinitialize of test via call to VA start or VA copy. To initialize, VA list, VA start, right? Another VA list, and then copy VA list object, okay. Count from this one, right? And I guess this is one of the problem using variatic function is that we have no idea when to end, so we need to provide this, right? VAN args1, okay, this one, some, okay, VA args2, another one, yeah, this make me curious how printf implement the variatic function, you know. Printf, if we take a look, right, printf also use variatic function, but it knows where to end, I guess, without providing the count. So yeah, how did the printf handle things? Args, okay, double. I'm almost the VN is FP into, okay, to be reset on the next call. What is the problem again? Check fault when using VS and printf. And then is that an explanation? Let add most size bytes, including the terminating null. Most size bytes. Do we need to change this using the variatic function? Oh, okay, wait, check strings. Okay, char array, alright, size, and then okay. If that is the case, then yeah, we probably need malloc. The benefit of using this is that Where is it again? Oh, this one is that we can have a, what is it called? We can have a custom error message, right? Alright, I almost forgot to increase our RC, release candidate version, right? Yeah. Okay, this is interesting. Do I want this? Maybe. I mean, when we passing, FMT, right? FMT. Let me cross check first. FMT, okay. Insert. Oh, this one. This one to FMT. This one is the variadic argument, I guess. Yeah, I mean, the problem with this one is that we might exceed the allocated character, right? So, do not write more than size byte. If the output was truncated to this limit, then the return value is the number of characters, excluding the terminating null bytes. Then to the final string if excluding the terminating null. Okay, this is interesting. So if the output was truncated to the limit, right? The return value is the number of characters, excluding the terminating null bytes. That's what we. So if we exceed the limit, do we have the terminating null bytes too or not? I mean, if we didn't have the terminating null byte or the null terminator, right? This one, it can cause buffer overflow if we exceed the limit. So, which should have been written to the final string if enough space had been available. Size, a return value of size or more means that the output was truncated. Caveat, where is it? Some programs imprudently rely on code such as the following. To append text to above, however, the standard explicitly note that the results are undefined if source and destination buffer overlap when calling. Okay. Excuse me. Depending on the version of GCC and the compiler option employed, calls such as the above will not produce the expected result. Confirm that is BF as described above. They would since GCC, since Kilip, okay, until Kilip, they would return -1. Alright. Interesting. Should I use this one? Has been assume an arbitrary long string. Careful not to overflow the actual space. Okay. Well, let's take a break first. Oh, yeah, it's kind of interesting. I mean, like, okay. Right, this might cause an overflow, and that without problem, but long string crash. I should have known that undefined behavior is never and will. So why do we need to copy this? The VA list is consumed and then you expect it to be reset on the next call. So when VS and printf consume the variadic argument list, does that mean it become empty, something like that? Interesting. Maybe let's try that out first. Playground. Variadic function.c. thing, right? And then variatic fun. What is it? Count. What is the difference though? Like C programming VSN printf versus V printf. Like what SN stand for? Got correct one and kill libc. Okay. Normal use on printf like function all. Let's do since printf takes many arguments, one VA list argument. To take VA list argument instead of a variable number argument. So here is the complete version. Okay. stdr fmt args. Okay. We start. C programming VA start. Palm. Just the variable argument, right? The name argument palm. C23 shall be invoked with an instance to a valid before any calls to VARs. If palm n is declared with register storage class specifier and a function type or with a type not type that result, the behavior is undefined. Only the first argument. With an array type with a function type or with a type not compatible with type that result from default argument promotion, where is only the first argument pass is evaluated, and neither expand or use in any way. Okay, count. And count can be odd made since, okay. This make me curious, though. Like, C23, but this one C99. So is C23 the newer one? 2017. I have no idea where. I mean, C17, C11, C99. So, let me go to the bedroom first. Be right back. Okay. Yeah, let's check this out. Per Oh. So because we didn't have pet, right? Oh, okay. We need to find that in the comment line, okay? Why there is an if? Okay. Oh, okay. Right. Okay, let me try this, but just printing it double, I guess. Let me find variatic function. That's the name, right? Okay, variatic. I don't think. Okay, pointer to constar. Okay. Constar. What is it called? Constar. What? FMT. Okay. Oh, VA Lisp. AP. Okay. I think we can combine this into one function. Let's try that out. VA Lisp AP, right? Oh. Yeah, let's try this first. Start, and then APFMT. Okay. State VSN print. Vprint, sorry. Vprint F FMT. FMT AP, print again, and then N VAN VC. Variatic. Print, I guess. Let's call it that. 2. Variatic function, non-variatic function, okay. Implicit declaration. Oh, okay. Implicit declaration. Wait, do I need to import? Oh, std-arg. Is that what I need? Okay. I need this one, std-arg. Let's try that out. Let me copy this one first. Variatic function. Okay, interesting. Okay. So if it is in one function, it looks fine. Maybe the problem is when we use that in another function. Okay, let me check that. Void print to cons char, okay, and then list, right? You know what, maybe something like this, and then parsing. Let's call it parsing. Void parsing. VA parsing. Let me change this. What is it called? Variatic print 1. Yeah, I mean, I'm afraid that it will conflict with the existing variatic argument. Function. Okay. List. And then we have that one. Void variatic constr fmt. printf. Oh no, not this one. List ap. Okay. fmt. ap AP, right? And then call this again. And now we are onto this one. Second, okay. What is it called again? Parsing FMT AP. Okay. Playground variatic function. Okay. All right. We haven't. Variatic function. It is working fine. So, what is the problem here? What is the difference, I guess? STT-lib. I mean, do we need STT-lib though? Let me copy this. It's working fine. So, maybe using different standard. Say 23 maybe. Working fine. Oh, interesting. Okay. I didn't know that when we copy the Stack Overflow answer, there is this comment. Interesting. That is why I don't recommend just copy and paste. Yeah, I cannot reproduce this. Oh, wait a minute. GCC macro, okay. What is the macro again? Pet, okay. Playground variatic function. Do we need to use CC? No, but yeah, I have no idea what causing the problem. define. Alright. Where is it? This one. Oh. I'll actually use. I mean, should we use variatic function? Type name. Let me think about that later. I mean, the point is to adjust this built-in operator with the new environment, right? Hello, Katya. Welcome. Why so much? What? K M. Oh, do you mean this variable? Okay. This is basically a variable name, or I guess parameter name in this case. So we have this like MMO. What MMO? I don't get it. Which M? let's go back in here first. Okay, for now let's use this one, right? That's basically what an assert type. We are using assert, but with custom error message, which is, I guess, nicer, but at the same time can be complicated to handle, so we will leave that for later. And then this, okay, before I forgot, let me add a to-do list. Where is it? Try using custom error message with format specifier like and then we pop that this one. Okay, I don't understand. What is with all those this and lines? With which one? All those this and lines. This one. Okay, this is just what is it called? Function name, or maybe this one. Yeah, this one is called macro, as far as I understand. This is the macro name, which I guess can take this argument, right? We have func, and we use this here, and we have args, we use this here, and maybe another one too. We use index, okay, like this, and so on. On the black screen, this one. Oh, this one. If this is what you mean, then this is basically just a tab character, you know. So when, let's say, I have space, I have those, what is it called? Where is it? No, not this one. If I use space, it will become dot dot dot. I have an indicator for trailing space, but if I put a number, it disappears, right? So this is basically just a for tab character. If you know about, what is it called? This one, \t. This is indicator that this character here is tab for using the indentation. and I can, no, not lips, but lists. I guess I can turn that off like this. So this is without the tab indicator, right? But yeah, some people make like this because it looks clean, but at the same time I didn't know the difference. Where is the tab, where is the space, you know? So I add this indicator as a tab character indicator. So I know that this dash and dot is basically a tab rather than a space. So let's say I do this, right? So there is a tab, character, and space in here, in this line. That's just a visual representation, if that's what you mean. If that is what you mean by dashes and line. Okay, where is it again? STLCMP, okay. Alright. Oh. Okay, this one, right? Okay, and then while the count more than 0, so when I delete this, it become a space rather than tab character. Just a little bit information. Pop again, okay. We're popping the value. Okay, we add this like usual, right? Nothing really changed there. And we delete the next memory, or free the next memory. Okay. Delete the value. So what is the difference here? Where is this use, you know? There is E in this one. Where is this use? OPAI, right? From this one. A from this one. The OP in this one. And file num is just the type. Basically, where is it? Basically, this one, right? We have this enum type. And then alpha pop Right, where is the E being used? You know, A, X, X, Y, Y. Right, X, Y, Y, division by 0. Okay. Right. Do we need this one though? You know, right? Well, guess what? Let me just copy this and check this in Vim. E. E. Okay. This function parameter didn't get used. So why should we add E? Or maybe right? Why should we add E then? You know, let's take a look at another project example. Maybe alpha. Okay, this one, right? Let me try copy this one and see if we actually use this function parameter, you know, like, I mean, if we didn't use it, then why should we provide the function parameter, right? That is still element on the list. No. And guess what? It is not used. The function parameter, we are not using function parameter environment in here. So why should we add that in the first place, right? Let's not add that. I mean, sure, it makes things consistent, I guess, but what's the point? Am I liking or no? Okay. PT, okay. And yeah, I'm variable evaluation, okay. Variable symbolic expression. Wait a minute. Okay. I mean, do we need this function to again? We didn't really use this function parameter, right? Let me check again, just in case I miss something that actually used the environment function parameter. Yep. Okay then. Looks like we didn't use this one. To the correct type, we can create a function that registers all of our built-in into an environment. For each built-in, we want to create a function alpha and symbol alpha with the given name. We then register this with the environment using lenv put. We want to create a function alpha and symbol alpha with the given name. Then create this with the environment using lenv put. The environment always takes a return copy of a value, so we need to remember to delete these two alpha after registration, as we won't need them anymore. If we split these tags into two functions, we can neatly register all of our built-in with some environment. If we split this tag into two functions, we can neatly register all of our built-ins with some environment. Okay. lenv add built-in. Where is the list head? This one, right? Built in. Is to call this new function before create the interactive prompt. We also need to remember to delete the environment once we are finished. This makes me curious though. Does this mean we are replacing this built-in function? Let's check this one. Built-in OPTI. Built-in Eva. Built-in head. lenv_get. Where is it? Continuing at the top. Now this is interesting. It looks like we are really replacing this built-in one with this one. Right, I mean, where do we use this again? If I remember correctly, it should be in this one, right? Let me commit this. Playground add variative function example. An example of using variative function. I mean, to create a function similar to printf. Maybe adding one more. Variative function. Now we are talking. That is interesting. Okay, where is it? This one, right? Reference. If I can type. I create another one, list VC VA copy ABC. Wait. Oh, we can. Okay. How many do we have? We have the POSIX one and the library one. Okay. Destination and source. Okay. Destination is APC and the source is AP. Okay. And then wait. It's APC and APC 2. Playground. What is it called? Variatic function. Alright, interesting. Variatic print. Variatic process. Okay, what should I add in here? The process, right? Char and also a list. Okay. Variatic process. Char fmt. List ap. No. Let's add this. If this bad, print DAP. Okay. Else list VA copy VCAP. Okay. This one should be APC and then what is it called? VAN APC. And if, okay. And if, okay. Oh, right. Okay, if AP, okay. To run this, the bad example, we can use this command. Okay, the bad function, background variatic function. This is an example of exhausting of using variatic arguments multiple times, which can result in unexpected behavior. Okay. The bad example. Example is an example of using bad is an example of using to prevent that. We can use copy the variatic arguments and use the copy value instead. Okay, let me put this in here. Variatic process FMT AP. Okay. Variatic. Gone. If I can type correctly, background variatic function. Okay. Now let's use the bad one. Bad variatic function. Okay. Alright, interesting. I'm still not sure why in this example we can use like two words, and in my case I need to use 3 words. I still have no idea. This is an example to trigger the bad scenario. Still not sure why using two function to argument works, but not using one the argument. You know what? Maybe let's try this. And see if it works. Right? Bad. Okay. Variative function. Okay, yep. It looks like it works. Whatever that means. So why using two variative argument works but not one? I still have no idea. I know it. Oh. Now this is interesting. We printed multiple times. Oh. Yep. We print this one, right? The first argument from the variative function, and then we print the second argument here. We unintentionally found bug. Interesting. Okay. Background variative function. Okay. How do we check? GCC printf implementation. Is this one glibc? Can I access the website, or am I lagging again? Okay, oh. That is 24, okay. Intern fprintf internal mod flag 0. What is this? I mean, with printf, if I remember correctly, printf something like this, right? If we print that, oh, okay. I think it was when using this one, right? And we have the format warning. Expect a matching. Okay. Alright then. Let's try this one. Playground variatic function. Yeah, this is interesting. Okay. Is it because yeah, I'm not really sure either. Okay, let me add this. Maybe make a new commit, sorry, other than amend. Okay, char count reproduce the bad example of variatic function. Previously, I cannot of using variatic function when I use one variatic argument. Now when I tried using the variatic arguments, I can use the gibberish that was printed out on the second printf. Still not sure why we need at least two arguments to trigger the gibberish. Oh, sorry, to trigger the gibberish. To trigger the unexpected, sorry, undefined or undefined behavior. behavior or behavior? Where is it? Okay. Behavior, okay. Not unexpected but undefined. Now let's put this in the amend. Right. Okay, commit amend, no edit. Okay, alright. I'm kind of curious again. Playground, variatic function, okay. It's getting worse. Now let's add another one. Yeah. It's really getting worse. So at least 2 variatic argument or whatever it is called. Alright. Okay. What is it? Okay, in the put, alright. LF built in. Okay, oh, okay. Built in. Yeah, I think we need to change that into void. Okay, first thing first. Join, use join. Fun. Now how do we use join? Wait. Environment, right? Delete, get, put, and then variable evaluation. Okay. Well, let's take a break. Okay. Okay, let me go to the bedroom first. Be right back. Don't forget to drink water. Yeah, I honestly have no idea why we need to implement this, Like, let me open this in a new tab and check this one. Oh, wait a minute, I didn't look at the expression bonus mark? Get a macro. Okay, macro, no. With the empty list, nah. Add a built-in function const that takes a value and appends it to the front. Const a value and a code expression and appends it to the front. Let's add the number of elements in a code expression. Oh, init returns all of the code expression except the final element. Let me write this first. Except the final element. Okay, This is actually interesting with empty list, especially the length, right? And that returns the number of elements in code expression. And built-in function cons that take a value and a code expression and appends it to the front. Value and appends it to the front. What expression? Except the final element. I mean, is it really called init though? Init function. Except the final element. This might be useful of element in code expression cons. And appends it to the front. What is it in here means? Is it a value? Like we append a value in front of the code expression? Is that it? Like what is the expected result, you know? Like is the value at the middle, like code expression, the value code expression, or the code expression, and a value? Like what is the input for this function? What is the expected input for this built-in function? For length, I think I kind of understand, I guess. Maybe something like this. What is it called? I mean, I kind of forgot. Sample. Maybe 6942. This is 6942 maybe something like this. For this one built-in function name, but the cons I have no idea how to use this. Is it like cons? Again, 6942 and then 6942 like this, or what? My understanding of Lisp is still limited, you know. Well, let's check that out. Lisp programming cons means how does cons work in Lisp? This one, right? And I'm not explaining in Lisp programming. In the part of my studies, I encountered the below example. Why when we have cons, the response is okay. And why when we change it a little and put the A after AP, the response is a dotted list like the first code line. And what is going on behind these codes? Oh, right. I think, yeah, I've seen about this book before. Wait a minute. This one, Practical Common Lisp. Let me copy this in the chat. I'm not sure. Can we add this in the reference in the description? Okay. We exceed 21 character. What should we remove? Maybe the web archive one. Let's see. Memory segment. Do we need this? Let me take it. Web archive. No, not that one. Basic integer overflow. Let me check. Eureka. No, okay. Machine code, okay. Latest struct. Coding style. Rational. Caesar array. Okay. Take group upward. Implement, okay. clockwise. Okay. Arrow operator. You know what? Maybe let me check this. Where is it? This one, I guess. Let me try remove this. How many? Okay. Save. Alright. Okay. They call it lips for a reason. This processing. Please remain in the language because they are excellent. There is no list. Console. Okay. A console consists of exactly two values. The normal notation for this is to use the dot. But since lists are used so often in lips, a better notation is to drop the dot. These are made by having the second element be a new console with the last ending terminator. These two are equal. Okay. Oh, alright. Cell. Yeah, I'm not sure if I want to implement cons. I mean, yeah, like the definition is, what is it called? I don't really understand what cons should do, but this one, len means hola for zero. Okay. Implement length might be interesting, you know. Should I implement length first or I mean number of element in Q. You know what? Maybe implement length first. It is kind of interesting. Number of element in quote expression. So with that in mind, let's wait. Oh, okay. We update the RC, the release candidate number. Yeah, kids test, and then it is .h clips.c. right? We need to add the length 30s. This is getting lengthy. Let's see. Join alpha, join right. And where is it? The header for join. So we call it alpha. Where is the alpha? Oh, in this one, in the build one. In the built-in function, okay. And join. Wait, hold on a minute. My placement is kind of interesting. It should be at the bottom, right? This one should be in this one. Join take pop, okay. Alpha take. Main, okay. What is the example again? Alright, okay. Lips, okay. Git commit refactor. Alpha join. Take. Instead of alpha join after it is at the top, feel like thing ever join after make searching easier because we can just scroll down and we can just scroll down instead of scroll up to the beginning of file, which is near at the top of the file. Instead of scroll up to the name of file, that searching easier because currently alpha join is only used in join and can just scroll down in the file to next function. To the beginning of a file. Okay. Right. Refactor done, and then we might add this one, the built-in length. I think this is kind of similar to Lisp. Oh no, not Lisp, guess. or Eva. Get the total of code expression parse. modify that, I guess. Okay, I think we will implement this in the next session. Let me post this first. Alright, I guess we will implement this in the next session, so that's it for now. Thank you for watching and see you next time. Bye bye.